Hello guys, so welcome to the sixth video. We are going to discuss this problem. This is a pretty trivial problem again. Don't look at the wrong trial. I was doing it when I was the most. Yes. So this question is a very trivial problem, and this problem is known as knapsack problem, 0 1 knapsack problem. So if you haven't read the problem, go read it and pause the video. So let's see the problem now. So you are in a bookshop which sells n different books. You know the price and number of pages of each book. You have decided that the total price of your purchase will be at most X. What is the maximum number of pages you can buy? So let us see. So what you have is that you have X rupees only, right? And you have some books, right? You have some books. You have some particular number of pages, even right? And you want to select those books only, and you want to select some of the books, and such that, and there's some price also. So for price, I would use capital P, P1, 2, and P2. And from these three, you can select any of these books such that the total price of the book you select is not greater than X, right? So how do we approach this problem? So basically, for each book, what you have options here. Each book have two options. Either you would take this book or you won't. Right? These are the only two possibilities for a book. Right? Either you take it or you won't. And similarly for the third one, either you take it or you won't. Right? If you consider all these possibilities, what would be the total number of possibilities? The total number of possibilities, if I have two options for everyone, so it would be 2 power n for n books, right? Is a basic combinatoric. So we have 2 power n of 2 power n possible permutations, and out of which we want to include we want those permutations in which I have received the maximum number of pages. So how do we do this? We want to break this power n to something less, right? And let's see the constraints over here. N is up to 1000 and x is up to 10 power 5, right? So we are clear with our approach here that we want to include all these possibilities. Right? So if we write a recursive function here, right? If we write a recursive function here that takes in a particular value, right? And the array itself, I'm not actually taking all of these, so I have these values, the max values, and the array, the price array, right? And pages array, right? And a current index, right? So of these combinations, either I would take this current index, so and the current current sum also, current price, right? Current price would be the total price we have paid for the book. So if our current price increases our max value, we have to return, right? We don't want this thing, and we instead of this returning thing, what we can do is we can make a check as well, right? So for C index for max value, I would say that max value comma price array comma pages array comma C plus one, right? And the next thing would be that I would be increasing C price by price array plus a price array E, right? And I have to track the number. I have to track the number of pages also, but that's a secondary thing. So because that would just require another variable. But the main thing to note here is that my price plus price array C should be less than equal to max value, right? Less than max value. Actually. So if it is less than max value, only then I can increase my price, right? So this was all for our approach. So this was our DP approach. This was our recursive approach. So let's see how the recursion tree is working now, right? So let's try it. Right. So basically, we have some max value here and comma some pages that we would take, right? And for each index, for each array, for the array, there would be then there would be two options that I would take it or not take it. And if I took it, then there are another option for the rest and minus one element. Right, either I would take it or not take it. So as you can see, there can be some overlapping subproblems as well, right? So what are these subproblems? So if suppose I took it, right? Now I want to find this much, right? And suppose I didn't took it, right? Then also I want to find this much, right? I want to find the result also. So I would calculate my result two times when I can calculate it one and store it on this, right? It's a classic classic Knapsack problem, and I think you might have, if you haven't, if you are not familiar with the Knapsack problem, please have a look at the at any of the these for these article or any other YouTube video because the Knapsack problem is pretty basic and there are a lot of wonderful videos made on it. I would just jump to the code section. Right? So let's see the code. Pretty simple code. So what I've done is stored the price and pages in a vector, and I have maintained a 2D vector named dp with size n plus 1, and I have initialized it with the vector of x plus 1 size and with the 0. So my dp looks like this. Our dp is the n cross x matrix. All right. So I have an n cross n matrix and dpij. So if I am here, if I am some index, if I am at some index I comma j, either I can not choose our current index or not choose our value at our not choose the book at our current index. So if I don't choose it, our answer would be dpij is equal to dpi mentioned j, right? I am not choosing my current index. I would just take it from upward, right? And if and then j minus price is I denote here that I want to have this x, right? So here is my some j minus prices, right? And I would compare these two problems and output the maximum of it, right? So it's a pretty simple problem, pretty simple math problem. If you, I hope you understood the problem. If you haven't, please roll back to the problem, the video again, or what you can do is to search Knapsack problem on Google. You can get a variety of great articles. These two weeks have a wonderful article here. Also, there are many other articles called Zero One Knapsack and videos as well. These two weeks might have a video as well. Yeah, so they don't have a video, but many other YouTubers have created a wonderful video. So you can have a look at that. This is a pretty. So let's see the next question, array description. This is okay. This question is a little trickier than other one. I mean, it is a medium level question, and This question is a medium level problem and it is a little tricky to solve, but yeah, it is a little bit tricky. I have to admit it. But I think yeah, if the idea clicks to you, then it clicks to you. It's like this. So till then, try this problem, and if you like the video, please like it. I don't want to try gossip. If you like it, then okay. If you want to like it. I don't force you. So till then, bye bye.